take a look at this problem. So we are given this function is seems like it's spinning around and around to me. I think it's spinning around and around. So we have an amplitude of 30 sine 50 pi x minus 7 pi thirds. So 30 is the amplitude. 50 pi x. That's weird. And then you have 7 pi over 3. That seems like that's shifting the graph to the right to me. So back in college algebra, we had, x minus 1 or whatever. It shifts the graph to the right, shifts it to the right. If it was plus, shift it to the left. And so that's what I think that 7 pi 3 is doing, is it shifting it to the right. Okay, so that's the function given. It didn't ask me about shifting, but I wanted to talk about it. It asks, what is the minimum value of x? I just realized it's actually t, so this is changing with time. It asks, what's the minimum value that t can take for I of t equal 15. Now we know that's not I times t. That's a function. And there's some t value which causes this sine times 30 to go to 15. Some t value, minimum value, is what we're looking for. So I don't know. I mean, roughly, I don't know what the answer is. And that doesn't that doesn't give you much confidence. But I mean, truly, I can't think of this graph. So I'm gonna have to take it by pieces because this isn't one I would just have memorized. But it equals 15. Yeah. Okay. So, and again, solve for t. I think it's pretty clear we're working with radians with a given problem of 7 pi, thirds, 50 pi. Looks like we're in radians to me. So I don't think that's much of a stretch. But again, they want to solve for t. So it's kind of like an algebra problem stuck in a trig function is what it feels like. So it kind of feels like an algebra problem. But I don't know. I mean, I look at this, I don't know what it is. So I want to solve for t, but t is stuck in the argument. And that's not a good place because I'm trying to solve for it. I'm going to start moving things around and seeing what happens. I'm wondering if we divide both sides by 30, we can at least isolate the function we're thinking of. Let's at least isolate it and see what happens. So 15 divided by 30, well, 3 times 5, 2 times, well, 1 times 15, 2 times 15. That's going to give me a half. And then we have sine 50 pi t minus 7 pi thirds. Okay, still ugly, but at least I have an idea what's going on. So roughly, what I'm looking at right here is sine of some angle equals 1/2. But this is the angle that we're talking about. This is our angle. So sine of some angle, that's a pretty ugly angle, equals 1/2. But we know on the unit circle where sine equals 1/2, right? Because we know that sine can only take values between -1 and 1. We know that's true. But we happen to have memorized where sine equals 1/2. Okay, so I'm going to pull out my unit circle here. Get yours out too. I think there is an angle here and which the y value is 1/2. There's another angle. I'm going to call it something else. The other angle, phi. How about that? There's another one where the y coordinate is 1/2. And I have those angles memorized. Okay, this is √3/2. I don't think we need to know that, but you never know. √3/2. So the x is negative on the left-hand side. It's right on the right-hand, or it's positive on the right-hand side. But this is dealing with the y value. What is that angle what's the angle where sine equals 1/2? So we have this one memorized. Other than 0, it's the first one we memorized. It's pi/6. So that was at least going counterclockwise, that's the first one we run into. Okay, but what was that other one? I always forget the other one on the other side. But someone taught me a pretty slick trick. I'll just review it with you now. If you don't remember how to get there, you know that it's symmetrical, right? But you could do pi/3, 2pi/3, 3pi. Whoops, that should be a 6. I'm teaching a slick trick in the wrong way, huh? Let's go back. Ah. 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 This was supposed to be a 6. This is 3pi/6, which is 1/2. This is 4pi/6. And this is 5pi/6. Okay? That's one that we actually have memorized, but once we get out of the first quadrant, sometimes we have to remind ourselves where that is. There it is. Okay. It's the sine of the angle 5pi/6 is equal to 1. The sine pi/6, 1/2. It wants the minimum value of t, not the minimum angle, the minimum value of t. So I have to somehow solve for that. How do I do that? Well, I don't know, but I know I have to solve it somehow. So this angle here, this guy, has to equal pi/6 or 5pi/6. It's one of them. It's one of them. And we want the smallest value for t where that occurs. Let's find some values of t, huh? How about 50pi t minus 7pi thirds equals 5pi/6. And then we're also going to have to do pi/6 and see which one. We have to test both because we have to see what happens. Okay, so from here we go 50pi t equals 5pi/6 plus 7pi thirds. Denominator of 6, denominator of 3. If we double it, we have the same denominator. So that'd be a good place to start there. So here I still have my 5pi/6, but here I have 14pi/6. Does it make sense that I'm doubling it to get it in the same denominator? To add them, we have to do it. And we want to add them because we want to condense them down. So now I have, it's getting ugly, but we're almost there. 14 plus 5 is giving me a 19pi/6. I would reduce if I can, but 19 is prime, so that's not reducing. I'm going to divide both sides by pi. My pen's getting fussy, so I don't know if I can do all my color tricks. But if I divide both sides by pi, this reduces. That reduces. Okay. So now we have 50 t 19 6. So we're ready to solve for t now. Divide both sides by 50. Reduce if you can, but I don't think there's a 19 inside 50. So I think that's about it. 6 times 5 is 30. So that leads me to think this is 19 300ths. Okay, that's one answer that could be the answer. I'm going to write it up here. More space. Need more coffee. Hey, you know how it is. Okay, let's get rid of some of this. This is the arithmetic part of the problem, but it's always good to practice fractions. We all could use more practice with fractions. Me especially. Okay, let's do different colors so we can note. This one. Different color that will show up on the board. I think orange is not bad. All right, again, I have this other angle, pi over 6. Pi over 6, that it could be 50 pi t's 7 pi over 3 equals pi over 6. Let's solve for t, see what happens. Very similar problem. 50 pi t equals pi 6 minus 7 pi thirds. Now, again, we want the denominator to be the same, so that 3's got to turn to a 6. We've got 50 pi t's 1 pi over 6 minus 14 pi 6. Should be a plus. Sorry about that. So we should have added 7 pi over 3 on both sides, not subtracted. All right. Sorry. Slip of the pen. Now, we've got 15 pi over 6. So we can divide both sides by pi. Pi goes away. We have 15 6. Well, that's the same thing as 3 times 5. 3 times 2. That's 5 halves. So now we have 50 t's equals 5 halves. So that would give me t equals 5 halves times 1/50th. So that gives me 10. 10 times 2 is 20. That gives me 1/20th. That's another possibility for t. T, 2, 2, t. Okay. Question asks, what's the minimum value? I've got two. I've got two that I'm thinking about. I'm thinking about 19 300ths and 1/20. If you're having trouble knowing which one is the bigger one without using a calculator. If you want to know which one the bigger one is, if you want to know which one the smaller one, here's a trick for you. You can cross multiply and then look at them. There's a theorem that says if you do this, we'll be able to find which one the bigger one is and which one the smaller one is. So 19 times 20, well, that's almost 20 times 20, but it's not. So it would be 400, but we could subtract another 20 and that gives me 380. Okay. And then 300 times 1 is 300. So it looks like this one is the smaller one. And that's actually what the question was asking us, which was what was the smaller value? And that corresponded with pi over 6. So it seems like even though we get the same output, it asks for what's the smaller value of t. So I would go with 1/20. My only puzzler I'll leave you with is there a possibility of having a negative t? Could you have a negative t which would give you the same value? I think you could, but it's going to be at the same location. So it kind of just depends on what you're thinking. So you could go from this direction to here. And you could find a negative t, which would get you there. That's a possibility. And you can also go this way and find a negative t, which will get you there. And technically, the negative t would be smaller, but it's the same location. So if you want the smallest positive value, I would say for this particular problem, it's 1/20. So that would be my guess. Okay. All right, so hopefully that's helpful to see that worked out, but it kind of turns out like a algebra problem mixed up with a trig problem. How I see it.